لسه ما بدينا.
بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على أشرف الأنبياء المرسلين نبينا محمد عليه وعلى آله أفضل الصلاة وأتم التسليم. أهلا ومرحبا بكم مرة أخرى، وأهلا ومرحبا بمن يتابعنا عبر رابط البث المباشر لهذا المؤتمر والمعرض. أهلا ومرحبا بكم في اليوم الثاني وأعماله لمؤتمر ومعرض سادكس 2025. نرحب بكم الآن ونرحب بالمهندس سامي إبراهيم سرحان، كبير المستشارين بالمركز الوطني للتنمية الصناعية، يتحدث إليكم عن تداخلات الدرون والثورة الصناعية الرابعة. أهلا ومرحبا بك مهندس، حياك الله، تفضل.
طيب، بسم الله الرحمن الرحيم. شكرا أخي محمد. تعريف سريع كذا عن نفسي. مهندس سامي إبراهيم سرحان، بدأت مشواري من أرامكو السعودية، بعدين انتقلت إلى جامعة الملك عبد الله للعلوم والتقنية، اشتغلت معاهم تقريبا حوالي 14 سنة، والآن أنا كبير المستشارين في المركز الوطني للتنمية الصناعية. خلينا نبدأ البرزنتيشن. طيب، استسمحكم بس أنا حتكلم باللغة الإنجليزية، ويمكن أتداخل ما بين إنجليزي وعربي، إن شاء الله بإذن الله تعالى نقدر نفيد قد ما نقدر يعني. لما نيجي نتكلم when we talk about Industry 4.0 and the list of technologies that it has, drone is one of them and probably is one of the pillars of Industry 4.0. But before that, I'd like to give you a very high level of what is Industry 4.0. A lot of people might ask, what do we mean? What are the various revolutions that happened? Starting from Industry 1.0, back in 1784, it was based on mechanizations and people. And then we had Industry 2.0, it was mass productions back in 1870. And then with the boom of the dot-com and electronics, we had the Industry 3.0 in automations and computers. In 2011, Hannover Messe, there was an official announcement of Industry 4.0. That being the cyber-physical system, Internet of Things, AI, and rest of the stack of technologies that we have within Industry 4.0. Now, someone can ask, is there Industry 5.0? Answer is yes. However, Industry 5.0 will not be addressing any particular technology. The European Commission in 2021, 10 years after the announcement of Industry 4.0, they've decided that Industry 5.0 will focus on three things: human-centric, sustainability, and resilience. And the idea was that there was a hype that Industry 4.0 will take away some jobs. So then they've decided to say, look, Industry 5.0 is actually human will be in the center of that interaction. Now, when we talk about Industry 4.0, there's a stack of technologies under that. Obviously, both AI, artificial intelligence, Internet of Things, robotics, all type of robotics, whether cobot, whether humanoid, 3D printing, is additive manufacturing, augmented reality, big data, cybersecurity, and the list is actually much longer than that. Drone is one type of robotics, and it is actually one of the, we were visiting one of the companies in eastern regions, and he was telling us that they actually manufacture robotics, and my mind went immediately to industrial robotics, and then after we were speaking, and he was saying, no, it's actually UAVs. So they consider UAV or drones as one type of robotics. So without going further, so we understand that drone is one element of Industry 4.0. When it comes to the capability, I'll talk about it and I'll give you a lot more examples why that is the case. So as an analogy, Industry 4.0 is data hungry, okay? Everywhere you apply smart manufacturing, everywhere you try to apply, you wanted to apply advanced manufacturing, you will require a huge amount of data. So then drone basically act as a mobile IoT, okay? It generates data from areas that cannot be generated from regular devices in the factory, okay? By flying over equipment, by flying in warehouses, by going up into the sky, it actually captures different type of data that actually can be used as by the Industry 4.0 various technologies. For example, we all know in order for your AI to become strong and you get the full analytics and the full decision, you will need a lot of data. Obviously, it feeds that data, for example, not necessarily, but for this particular example, it can feed to a digital twin, and then obviously, it will help you in automotive, automatic analysis and predictive maintenance. Now, we spoke about Industry 4.0. I'm going to give you this analogy. It started with human working on a mechanical systems, okay? and was mainly on labor-based. And then we moved into mass productions with the boom of electrifications. And then obviously we had the automations slowly until we have our smart industry, where now autonomous systems, where some of these machines work based on data, based on some sort of objectives. On the same analogy, the revolutions of drone, slowly, we might not be there yet, but slowly, we're going to move away from a pilot-based drone into automated-based drones. Already automated drones, already flying. Pilot being a standby just to actually understand what actions needs to be taken. Did we reach autonomous? I don't know. But we're gonna discover this together today. Now, autonomous means it's a real-time AI advanced sensors and additive decision making. If we look, for example, or take example Tesla. Tesla car, when you actually switch the autonomous, what it does, it looks at every single corner of its path to understand, to make sure that is actually going to the right path. If somebody comes in, it actually takes a break. Not only that, it collects information and data as it goes. And that's what we mean by adding more data into your decision that will help you understand if you're really going through the path or not, okay? So we think that we still have piloted drones. We still have drones that are flown by pilot. The automated is actually happening as we speak. There are already programs, but autonomous, I think it's going to be some time. Now, someone can ask, what do we mean by autonomous? This is a level of aerial autonomy. So just to give you an idea, what do we mean by autonomy? From level 0 all the way to level 5, if we look, for example, what does the pilot or operator have to do at level 0 is 100% stick to the input. It actually gives all the input to the drone to fly. However, at level 5, you don't, as a pilot, you don't even touch the drone. You just set objective. In my next slide, I will explain what I mean by that. You set objective, and then the drone actually flies based on the objective that was set on. And as you can see in between, there are various levels all the way from for A, B, and C, and then level 5. Now, in my personal opinion, I don't think so we have actually reached to level 5 yet, okay? But we might reach soon. Again, what does the system do? Level 0 or level 1, system provides a stable vertical position. In here, system flies under all condition. Okay, so again, that's what I'm saying. We might not have reached to that yet, but soon we will. I think that the rapid technology that is happening, we will be able to reach to level 5. With what level of understanding that particular machine is, at level 0 and 1, you can say no understanding, estimated orientations and altitude over there, full understanding, okay? Now, you can imagine in order to build level 5, you will definitely need AI edge. You need an AI chip within the drone to be able to take decision quickly, to be able to analyze surrounding, and be able to fly as it goes. Now, that I explained, now this is very interesting. Back in 2022, I proposed this idea at the KAUST King Abdullah University for Science and Technology at the Robotics and Autonomy Conference. Dr. Eric Fernon, he is actually will be speaking at the last panel discussion. He is here. He asked me to talk about this. So what I propose is as follows. So the idea of objective, I was telling you, what do we mean by objective? All right? So this is obviously drawn in a box, okay? And you have a full site of construction. The idea is that you feed few things. You set objective. You tell the drone what is the objective of the flight, okay? And then you set some sort of geometric boundaries. You want to make sure that the drone actually flies within certain boundaries so it understands its limits. You asset identifications, you tell the drone what is expected, for example. What type of asset are we talking about? It's a construction site, so it's going to see bulldozers, it's going to see cranes, it's going to see all different type of assets. Then you also put a working shift, so it's very important for the drone to understand what is the good timing for it to fly and to get the data it requires. And then you put a scheduling data, some sort of high-level scheduling of the site itself. So we know, for example, site A probably will develop before site B, and then site C afterward, and that sort of things. When you input all of that as a parameters to the actual autopilot of the drone, then you expect the drone will plan its own mission. It will not fly over weekend because there might be no work there, okay? So it will fly, it will set its mission to understand when to fly. Send the data instantaneously. So as it flies, you will not have to wait for the data to be transmitted. The data will, as it goes and as it captures things, it will send the data to the back office. Process data on board. That's what I was saying. With an edge AI chip, you will not have to go back and forth for the data to be analyzed. It will analyze the data on board right away. And then, of course, it has a fail-safe and energy control. At any moment, when it feels it is actually running dry on its battery, it will automatically come back to the base and charge itself and be able to fly again. And finally, anomaly detections. If it finds something that is absolutely abnormal, it will quickly understand that this is something that we will need to highlight and we will need to quickly. Right. So when we talk about Industry 4.0, what are the areas drones can actually interact with? We're talking about safety compliance, autonomous inventory management, predictive maintenance, anything related to autonomous industry. Let me give you an example. IKEA, for example, in Europe and USA, they have implemented a drone within their warehouses. Basically, it reduced labor strains, fewer misplacement, and improved accuracy. Now, someone can ask, again, where can we use such a technology? Anywhere you have an infrastructure inspection, okay? You can use that, and a good example of this has actually been used as we speak by Delek US and Percepto drone, where it flies over the plant, look at the flare, understand the asset, capture anything abnormal, and send it immediately to the operator. And this is also another example of flyability, ALOS 3, where it actually enables to fly in areas where it's very difficult to go and maneuver. Obviously, the whole idea is that now it feeds data into a digital twin platform using Industry 4.0 integration. Again, where can we else use such a autonomous drones works the best? In continuous monitoring. Everywhere you have to monitor one after time after another. It could be a construction site, it could be an agriculture site that you would like to monitor on a regular basis, then that's autonomous could be a great area. And then, of course, one of the amazingly applications of drones is detections of normality. For example, gas leak detections. We know that there are now advanced payload that will help you to detect anything related to gas leaks, and it will tell you exactly where is that gas located with specific parameters. This is my last two slides. I want to just give you a very high level that when we talk about Industry 4.0, as we agreed from the beginning, and drone is part of it, we're talking about a huge market. This is something, by the way, already available. If you go to Invest Saudi website, you will see there is an investment opportunity card for Industry 4.0. As you already can see, the MENA regions and the KSA regions we're talking about $17.8 billion by 2030. Obviously, there are huge key drivers of it when it comes to the manufacturing, but as also in the ICT as well. And these are another sites, anything related to the value chains when it comes to hardware, software, and the rest of the stack of requirement of the value chain for Industry 4.0. With this, I'd like to conclude my presentation. Thank you so much.
Thank you, Mr. Sohan, and congratulations. That was very insightful. We will be moving very quickly on to our next panel. I'm looking for Mahmoud, our stage manager, to please put the names up on the chairs, and we will invite the panelists to sit next to their names, and we will start in a couple of minutes. Thank you very much. I'd like to invite the panelists to take a seat, please. If the panelists could come up to the stage, that would be great. Thank you.
See anything in that direction.
Before we start the session, I'd just like to say that we are short of one person. He's on his way, is he? Okay. He's on his way. Okay. We'll just put him over there then when he arrives. Thank you very much for joining us today. Just before we start, when you speak into the microphone, you need to be quite close. There's a little button here. Well, I think we all turned on. Are we turned on? If you could each test your mic, that would be great, because this goes on to YouTube. As you can see, we've got the cameras on. I think you need your button on. Can you test yours, please?
Testing this one, yes.
Yes, you need to be close. Can you test yours, your mic?
Test, test.
And again.
Testing 1, 2, 3.
Okay, it looks like we set up. Okay, good. My name is James Morgan, and I'm moderating the panel today. Edge drone applications and extensive operation capabilities across various sectors. So we have people from different sectors. What I'm going to ask you to do is to introduce yourself, name, the company you're from, what you do, and the sector you represent, please. Okay, Jordi, let's start with you.
Thanks. So I'm Jordi Salvador. I'm the director at Barcelona Drone Center. We are located in Barcelona, Spain. And we have been in the drone sector for a while now. This year, we've been lucky enough to celebrate the 25th anniversary of the company. And since its beginning, what we have been doing is trying to push forward all those drone for good applications. So today, with this new upcoming application, we're talking about drone delivery for the healthcare industry. We are talking about services for the agri-food industry, long-range inspection for infrastructure, so everything that moves towards these new levels of autonomy that we were seeing just some minutes before on the previous presentation.
Thank you. And Maximilian.
Hi, Max, my name. I'm co-founder and CTO.
Could you get closer to the microphone? Sorry, yeah. Thank you.
Hi, Max, my name. Co-founder and CTO of Avilus. Who is Avilus? Well, 4 years ago, the German army was thinking about building a flying stretcher to evacuate wounded soldiers from the battlefield. And back then, we as aerospace engineering PhD students started to design such a thing, founded the company, and started building the first rescue drone that exists in the world. We basically designed it around the medical use case to evacuate wounded from the battlefield. It was dual use from the very beginning. And then after some time, we realized that most of our work goes into the brain and the electronics of the drones. That's why we then also started retrofitting other ultralight manned aircraft to become drones. And now we basically are a developer and manufacturer of drones of a class between 500 kilograms and 1,000 kilograms.
Thank you. And John, if you could introduce, please.
That's right.
Yeah.
Hi, afternoon panel and the rest of the audience. My name is Bedon. I'm from Singapore. I'm the Vice President of the World UAV Federation Singapore chapter. My background is everything on aviation. I've been flying for about 35 years. And somehow I got involved in drones, so anything that flies happens to be my specialty now. Thanks.
Thank you. Is Dr. Singh anywhere in the audience at all? Because if he is, I'd invite him up to take the last seat. Dr. Singh, are you out there? Okay. Yeah. Okay, John, I know it's you, so I think we've got that. It's all good. So, Jordi, I'm going to start with you, and if you could please give us an idea on the examples from your sector with edge-enabled drones. So we're talking about edge AR chips, etc. If you could give some examples, case studies of some of the work you've done.
So one of the main things that we are working now in Europe is to make all this technology safety enough in order to be integrated with manned aviation. So one of the main points of development and research that we are seeing nowadays is everything related to detect and avoid and beyond. No? We are seeing this detect and avoid is just the first step on being able to detect that drone and avoid it. But then we need to recognize that other drone or that other manned airplane, how it's behaving. And here there is still a lot of work to do because it's not just properly detecting that potential threat for the operation, but also being able to act accordingly and in a coordinated way. So in this sense, is what I expect in the upcoming 1-2 years to see further development on sensor fusion, on adjusting these routes in a completely autonomous way, because at the end, for this type of situations, you want to have a really quick reaction. So being able to skip the confirmation of the pilot and being able to perform it autonomously, it can be of great value to increase the safety of this type of operations.
Thank you. Maximilian, can you give us some examples of the different sectors that you work in with your drones?
Okay, so we basically have 3 drones, an electric multicopter, the Cricket, or German it's Grille. This is the medical evacuation drone. It's dual use, so first of all, we built it for the German army, for the military, but also for mountain rescue, for example. I heard yesterday here that in Riyadh, there unfortunately is many traffic accidents and 3,000 dead people by car accidents each year. And if you ask the medical experts, which we know from the German armed forces, in these accident situations or when you're shot, 10 minutes of delay to get to the surgeon can cause a 3 times mortality. And everything that helps you to accelerate getting a wounded person to the surgeon is really helping there, of course. And that's why, for example, for traffic accidents, having these drones to evacuate people faster is something that is a very good use case to start with drones. This is example number 1. Then example number 2, we have a helicopter. The advantage of the helicopter is, of course, you have higher ranges and higher payloads that you can realize. However, you have higher maintenance costs because of the mechanics of the helicopter. And there you also have different use cases. So, for example, in Germany, we have a lot of offshore wind energy platforms. And there, when you do maintenance, very often you realize that a small part is missing. And then you need to fly in with a manned helicopter, which is super expensive, where you can actually send a drone that can deliver a part. That would be, for example, a use case for a helicopter. And then last but not least, we have a fixed-wing aircraft that is a strategic aircraft that the military, for example, uses for intelligence purposes. So there is sensors underneath that have a range of 370 kilometers where you can basically recognize ships in the ocean that switch off their transponders, for example. You can do surveillance on critical infrastructure with it. So everything that you want to do, border control, finding smuggling ships, this is things you can do with this platform. So there's many critical infrastructures from logistics to medical evacuation to critical energy infrastructure that you can support with these systems.
Thank you. John, can you give us some examples to illustrate the integration of edge-enabled drones on a large scale?
Okay, I would like to. I'm Dr. Prikwan, so never mind. I'll take my question first. How best illustrate the integration of edge-enabled drones in large-scale industrial operations? So, firstly, we must identify that there are 3 types of computing. One is edge computing, is what we are driving for now. Next, we have the fog computing, and we have got the cloud computing. So when it comes to edge computing, is what we are now looking at, is something whereby you can make quick decisions fast at a local scale with no lack of security threats. So I think that is going to play a vital role in terms of defense. It is very useful for us. And in terms of the agricultural environment, the executive can make decisions faster. And if we are talking about agriculture, if we are talking about cloud computing, we need to gain access to internet. And that takes about a lot of time to upload the information for the executive to make decisions. So when it comes to agriculture, there and then we can actually make decisions. The executives can make decisions there and then in the shortest possible time. After all, we know agriculture is going to be is currently the biggest market for drones growth in the entire world in agricultural countries. So I would say that the biggest industries are basically defense as well as for agriculture. yeah, many other purposes also can be used. Yep.
Okay, good. Are we going to start the next round of questions? I'll go to Geordie first again. From your point, from a different point of view, the deployments of drones, have they driven more efficiency? Have they driven more profitability? Have they helped in cost reduction? And some examples, please.
I will say it's something that may still be a little bit on the way. Let me explain how, no? And maybe it's good to have a reference from a project that we made some months ago. It was a project in which we were doing this healthcare delivery. Main thing, this was carried in nearby Barcelona, so it's in the eastern part of Spain. And we had their problem, that is that we have the blood samples that are taken to everyone early in the morning in the healthcare centers. This is made early in the morning because then there is a van that goes through all these healthcare centers, picks all the samples and brings them to the labs analytic that usually is in a nearby hospital. This means that we have here restrictions because of logistics. What we are doing now with drones, we are flying directly from the hospital to these healthcare centers, and this means a saving of time of 80%, and it means also that the quality of those blood samples, as they are reaching more quickly the lab, it's much better. At the same time, that this changes the paradigm of how we operate. We don't need to rely on a big van carrying all these samples, but we can do more point-to-point, more a network of deliveries, so then we don't saturate the number of samples that the labs receives. What happens here that due to regulatory constraints that are in place in most over the world, this type of routes that we're explaining now here can only be properly deployed in niche applications like this one, a certain hospital, certain healthcare centers. When we are talking about flying in the middle of crowded cities and those type of scenarios, we are not yet there. This means that although the potential cost reduction is there, we are talking about 80% time reduction, more flexibility, new types of services. The cost is not yet there because we are not in a point in which we are mass producing drones. Most companies are on the order of hundreds or thousands of drones, but not millions. When we reach this stage that all this can be extensively deployed and with this scale economy in the drone sector, cost reduction will be there also for the economic cost, not only on the time or the benefits or the quality, but also for the economic side.
What about the perishability of blood? Are these drones, the storage compartments insulated, right?
Exactly, yes. We have a real-time tracker of the temperature during all the flight, so we can guarantee that these samples has been properly been carried, that everything has been properly safe of any changes of temperature.
Thank you. Dr. Singh, thank you for joining us. If you could just tell us, tell the audience a bit about yourself, where you're from.
Hello everybody. Thank you for the honor of hosting me here. I represent the World UAV Federation. I'm the head of the chapter in Greece for the last 7.5 years. And it's my second time I'm joining SADEX. I'm really happy to be here in Saudi Arabia and interact with all these colleagues and friends from the drone industry.
Okay, great. So I'm going to ask you a question since you haven't been asked one yet.
Yeah.
In the context of urban management and smart cities, how can edge-enabled drones support infrastructure, monitoring, emergency responses, and environmental management?
Okay, it's a very good question. Actually, this is a necessity for the coming years. One of the major concerns we are having is how we were going to manage all the huge load of information we're receiving from sensors on the drones, or also how they can be integrated with the sensors we have on the ground. So the previous years, the challenge for us was to develop the necessary hardware and ready-to-use solutions. But right now, the challenge for the next 5 years is to have AI-based software that can support all these network of sensors we're having both on the ground and in the air. So in terms of the digital cities and any other initiative in that field, we have started providing solutions. And of course, the experts, the academicians, research institutions are already working for the next challenges. And like I said before, the biggest challenge is how we can integrate and manage the huge load of information. It's totally impossible to do that having humans monitoring 24/7 what all the information coming in. So what we're doing, we have provided an algorithm that can combine all this information and give you real-time updates ready to use for the decision makers.
Thank you. And Maximilian, because you asked about emergency responses, and obviously that's part of what your business does. Have you got anything to add to what Dr. Singh's just told us about in terms of, you know, operating your drones within cities and the challenges of that?
Yeah. Okay, for emergency...
sorry, Maximilian's answering this one, Doctor.
I'm sorry.
Thank you.
Okay, so we are flying our systems in the specific category of EASA, and there basically the certification always depends on the risk under which you operate these systems. And now, of course, there is air risk and there is ground risk. And then, of course, if you fly in a city, there is a higher risk level, and therefore the safety and integrity of the system that you need to demonstrate in front of the authorities is higher. So, of course, you have a lot more demonstration effort there and verification effort. On the other hand, what we realized in terms of one of the main challenges there is also that when you speak about the operation, that it's not just like technological innovation, but also an innovation for the operation itself. Transporting a human person inside a drone also poses many ethical questions, where you not just have to make it possible in terms of engineering or in terms of the certification of the flight, but also in terms of like the medical aspects and ethical aspects. So that's one of the huge challenges that is there as well.
Doctor, have you got anything to add there? Sorry I cut you off. Have you got anything to add to what Maximilian said there?
Yes, when we are trying to deal with response protocols, what's important is the human life itself. So time is our biggest enemy. So we don't have only to be efficient, we have also to be quick. So what we're trying to do right now is to give the solutions minimizing the response time. So this is absolutely necessary. And how we do that, we will respond the latency time when we receive the information from the air. And then we have the decision maker to have a situational awareness and then give the right orders to the right people, vehicles and all ground mechanisms that are going to do the rescue operation. In that terms, if we minimize from a technical aspect this response time, we give them the ability to operate much faster.
But how do you determine on the ground, in terms of a health emergency, whether you need an ambulance or a drone in a city? Because in an ambulance you would have attendants who would keep somebody alive, and I assume in a drone you don't have that kind of facility, right?
Actually, there are some applications, some very good initiatives. Ambulance, of course, cannot be replaced 100%, but for example, for other emergencies, like when we have natural disasters and when we have people missing or people trapped somewhere, we can use the aerial assets to give them assistance very quick.
Okay, thank you.
Yeah.
John, improvements in efficiency and safety. I want to go back to where I was with you earlier. As far as you're concerned with your technology, I think the safety issue, especially in city environments, is obviously of a concern to residents, people on the ground, motor vehicles moving around and things like that. How do you plan for that, and how do you build that into the decision-making, the autonomous decision-making models that you use?
So your question actually...
It was for... oh, you're going to answer it.
no.
Okay, you want to... Okay, good, good. All right.
Who's going to be answering? Again?
No, man, you answer.
No, he wants you to answer it.
Yeah,
So,
please.
if you don't mind.
Okay, thanks a lot. Okay, safety is a major issue, of course. Okay, so this responsibility unfortunately goes on the shoulders of the drone manufacturing companies. This is the primary concern. They have to follow the regulations, and they have also to comply with the policies and the risk analysis that aviation authorities of each country are trying to apply. So if we reverse the problem, when they start designing the machine that is flying over the cities, they have already identified the risks, and they have taken already measures, technical measures. So what is left when we're doing the operation is the operators. They have to be trained, and they have to be aware of these risk avoidance protocols. I believe in a percentage more than 90%, the problem is already solved, but still have much work to do about that.
Thank you. Geordie, I'm going to come to you now and just ask collaborative approaches, working with partners, policy interventions. You know, how does it, in Europe, for example, we have 5.0, Industry 5.0. We've got drones. How does this all work, and how do you overcome this barrier? Because you use hard technology. How's that human-centric, for example?
It's one of the complex things, no? Because we are used to build drones from the engineer's perspective. So a lot of drones still nowadays are a complex machine to operate, especially when we are talking about these advanced solutions. So having them more user-friendly is one of the main things to move forward. And here's again, is where these AI solutions can help in making some of the decisions. Getting back to the previous question about this safety, how the drone can be aware of what are the regulatory constraints that are affecting the flight. Because, okay, maybe you get an approved autonomous operation, but maybe it's just low-level risk operation. You cannot overfly crowds, or you cannot fly cities at all. You have to stick that operation outside cities. So these boundaries either have to be properly fixed by a human, or that drone will have to be able to properly sense what is the area that is flying, what is urban, what is suburban, what is the ground risk of that area, and be able to properly plan the route. There are already companies working in that direction, like Volan Autonomy, for example, in the UK, that can already generate flight paths that have been not only deconflicted, but also properly assessed in a safety and regulatory compliant level. And this already makes our flight more easy to plan, more easy to execute, making it more user-friendly for the final operator. We can expect that all drones will be operated by rocket science engineers.
Okay, and Maximilian, do you have anything to add to that?
Not from my side.
No? Okay. Doctor, I'm going to go to you again and say, you know, in terms of technical and operational hurdles and widespread edge drone applications. So we're talking about more kind of non-operated drones, are we? What are the technical challenges or hurdles, operational hurdles?
Okay, in response to that question, what are the technical challenges that we face when it comes to edge computing is, firstly, I think we must have a look at the infrastructure. Is the country's infrastructure able to support the enabled computing, to upload to basically support enabled computing itself? So that's the first challenge. Secondly is, I feel, of course, it comes to the rules and regulations. Drones rules and regulations, which is actually a build-up of Mr. John's concerns, that rules, regulations must be highlighted to the users very, very clearly. And I think the regulators must also be aware of them, because they set the pace for everything that is to come. Then, lastly, I think also it comes to the, again, it always boils down to the endurance of the drone itself. Because if we have got drones, take for example, agriculture drones, they need to sweep hundreds of acres in a very short time. So you cannot allow any form of deficiency, endurance time to, or any mechanical failures to occur, because you lose all the data that has already been uploaded into the drone itself. So I think those are the major challenges that we have. And of course, I would like to say we need competent people to actually see the data and analyze it and make decisions. I think it boils down to people itself also. They must be properly trained to analyze the data and make decisions or bring forward the decisions to the executive itself.
So in terms of edge, and then the kind of classic first generation of drones where we saw, you know, everything was human piloted, and then now we're looking at, you know, auto takeoff and that fully autonomous. Where are we in the world of being fully autonomous in drones? Is this going to take 10, 20, 30 years, or are we closer than that now?
I think when it comes to autonomy, I will again stress on the agriculture drones because that's the biggest market. I think to a certain extent we are already there, because if I want to sweep an entire farm, all I have to do is just give the waypoints and give its mission, everything will be done. So I think we are already there. But if we want to go maybe beyond visual sight range, then I think maybe a little bit more effort is required. But I think we are already here because so many trials have been done, so many practical examples are already there. So we are already here. And I think for the next 15 to maybe 5 to 10 years, it's just improvement. When it comes to improvement, I'm looking at infrastructure, latency, as well as, of course, security again. Security is a key issue now. So to confine it within that environment itself. So those, I think, are the developing areas that have to be nurtured within the next 5 to 10 years. Yeah.
Thank you. And John, finally, what are the main challenges on getting to fully automated drone utility?
Okay, like I said before, from a technical aspect, most of the issues have been already solved. So what is missing right now is the regulation and the standardization of the rules on an international level. I will give you a small example. For example, let's say one country has the perfect regulation, but for one reason must conduct cross-border operations, drone operations. What will happen then? This is a small example to understand that we still have gaps in the regulation and we still have a lot of discussion to be made. Especially in my part of the world, you know, well, in Europe and which is totally different than Middle East and Asia. Since 2021, we have common rules, common regulations on a European level, but still there are still gaps we haven't solved. We need to work on that, and once we have that, and then we have the flight approvals for fully autonomous flights, we can say we can increase the testing, we can finalize the testing period of the flights, and then we can execute.
So we're looking for best practice in a very young industry, is that what you're saying?
Yeah.
Well, that's, you know, the show should be bigger next year, and we hope to have you all back again next year in 2026. Probably double the amount of space as well, as the kingdom is adopting this technology in a big way. So thank you very much for joining us today. And everybody, can you give them a big round of applause for their expert knowledge and insights? Thank you very much. Thank you. Can I invite you onto the stage here? Is our photographer out there? Do we have our photographer? I'm just checking with the stage manager. Okay, we'll do it with the camera. If you guys, if you could join me down here, please. gas industry, the game changer, will be starting in a couple of minutes, and you will be hosted by Ms. Mohammed Al Thamali for that panel.
الضيوف الكرام، أهلا ومرحبا بكم مرة أخرى. نرحب الآن بالدكتور خالد بن إبراهيم الحلوة، وهو الباحث الأول في معهد التقنيات المستقبلية في مدينة الملك عبد العزيز للعلوم والتقنية بالعاصمة الرياض. سيتحدث إليكم حول البحث والتطوير في الدرون في المملكة العربية السعودية دراسة حالة. أهلا ومرحبا بك دكتور خالد.
ولا ممكن هنا؟ تمام لا ما احتاج اجلس. Good afternoon, everyone. The title of the presentations is Drone Research and Development in Saudi Arabia, a case study. In this presentation, we will talk about 6 elements. We will start with the cast information and description, and we will end with the conclusion. In 20 seconds, the Prince Mohammed bin Salman announced the national priority for the research and development and innovation. They focus in health, environment and sustainability, energy and industry, and the future economy. It is expected to contribute to 2.5% of GDP and 60 billion Saudi riyal in 2040. The national priority has 4 sectors, which is the health, sustainability, and the energy industry, and the future economy. For our case study related to drone research and development, we will focus in the last sector, which is the future economy. The organizational structure of research and development in CAST are really focused in the 4 sectors, and for each sector there are some research themes, and for each research theme there is an institute that really conduct the research and development related to that research theme. For our case study related to drone, it's really focused and related to the future economy on the last columns. As you can see there, the first research theme is the future cities, and the first institute is the future mobility. Through the Future Mobility Institute, we actually really interested in the drone research and development. The R&D strategy of the future mobility is developed in alignment with Vision 2030, national priority, national entities, and global technology trends. The focus area of the future mobility are 7. The first 4 focus areas on the left are smart mobility, autonomous system, smart logistic, and electrification. They are classified as a Tier 1 high priority. The 5th focus area in the middle, it is the avionics and aeronautics, and it is classified as a Tier 2 or medium priority. The last 2 focus area on the right are high-speed transport and the future economies. It is classified, they are classified as a Tier 3 or low priority. Next, we will talk about lab and capability. For the future mobility, we have 3 laboratories that support the research and development. The first lab is the microcopter lab, and this lab is really help doing the research activity, including design, manufacture, and testing of multi-copter system. Some of the services that this lab provide include 3D printing and sensor integration and testing. The second lab is the electronic system lab, and the third lab is the composite manufacturing prototype lab. This lab can help manufacture the airframe component of the drone. For the capability, actually the UAV program started in 2000. As a result, we have a great experience and knowledge about many areas, including aerodynamic design, structure design, prototyping, propulsion system, electronic and electric systems, and system integration and testing. Third, we will talk about drones type and application. From our experience and the project that we did in the past, there are three key types of drones. The first one is the fixed wing, which allow for long distance flight. The second type is the rotary wing, which has the vertical and takeoff land capability. The third type is the VTOL, which combine the future of the fixed wing and rotary wing design. For application, as you can see here, there are so many civil applications, including imaging, reconnaissance, surveillance and intelligence, disaster response, patrol and security, surveying and mapping, environmental monitoring and delivery. Fourth, we will talk about some of the drones' achievement. The first UAV project is the Key 1B UAV. This is a small fixed-wing UAV system that can be used for civilians and monitoring mission. It can carry about 5 kilograms, and the maximum takeoff weight is about 35 kilograms. The second UAV project is a drone for pandemic detections. This UAV small system equipped with AI and sensor and allow for thermal detections. It was used during the COVID-19. The third UAV project is the Tannan UAV. This is a rotary wing UAV that was designed, manufactured, and tested by CAST. This is a small UAV, which is coaxial octocopter and can be used for many civilian applications, such as delivery. The maximum takeoff weight of this drone is about 15 kilograms, and the maximum payload weight is about 4 kilograms. Next, we will talk about one example, which is related to last mile drone delivery, using the UAV that we mentioned in the third project. This slide shows some key feature in the left and the specification on the right. There are several mechanisms for carrying and releasing the payload, including release and drop devices and the use of a box. The specification on the right show many important facts about this drone, including the weight and the dimensions and the speed and so on. The Tannan UAV project phases include 3 phases. The first phase is the design, which include conceptual design, preliminary design, and detailed design. The second phase is the manufacture, which include airframe manufacture, airframe assembly, and octocopter assembly. The last phase is testing, which include ground test, flight test, and pilot test. For each phase, you can see below some of the pictures and the tools and software that has been used in the past. Like other drone project, this project faced some technical challenge, including mechanical vibration, high temperature, inefficient power distribution, campus issue, payload interference, aerodynamic drag, and environmental factor. Last, we will talk about a summary. The key element of a drone research and development include a vision, and this is a very important element. The second element is a strategy that align with the national priority. It is also important to have enough and good infrastructure like lab and digital tools. Fourth, it is very important to have resources, including engineers and technicians, and enough source, enough fund. The fifth important element is the focus area. And the sixth is the collaboration. The partnership is very important and can enhance the capability. All these elements can help and support the successful of the research project. Thank you so much. And they will be happy to answer any question if you have. تفضل. Some? Yes. Yes. For the last one, which is the 10 nano UAV, we mentioned two types of weight. The maximum takeoff weight, this is include everything, including the airframe, the propulsion system, and command and control system, and even any sensor or delivery or package. So this is the total will be about 15 kilogram. Part of the 15 kilogram is related to application, which can be the delivery, so that we can put a sensor that has a weight of about 4 kilogram or package for delivery and so on. Thank you. Yes. Okay, okay. Thank you so much. For the environment factor, there are so many things. And you mentioned two of them, which is the temperature. As you see, in August month, it's reached about more than 45 degrees. That's one of the issue that it can be, it can affect the performance and the achievement of our project. The second thing is the dust, because this is may really be a disadvantage and can be a challenge. Yes, and just for your information, we still for these two factors, we will we didn't complete the project. Actually, we are ready now for the testing soon, so that we will later see what can be done for this. But for your information, now we did a few things that will help us to get rid of this issue. For example, we add some cooling fan so that it will cool the electronics and electric component in the aircraft, and so on. So also we add a few things that will allow air to come inside the drone and cool the component, the internal component that has a high temperature. Yes. Also, we did many designs so that this will not be a big issue so far. And we will see this soon in the next few weeks. Yeah. Okay. Yes, the speed. Yes, it's a speed, it's about 60 kilometer per hour. Okay, for this, the last one, which is Tatannan. Just keep in mind, the rotary wing is really different from fixed wing. Fixed wing are really better for the speed and range and long endurance. So that for the fixed wing, the speed will be higher. Thank you. Thank you so much.
is entitled Drone as One of the Pillars of the Vision 2030, its critical role in the Kingdom's national transformation strategies. We will be starting the panel in a few minutes. I would invite the speakers on the panel to come up to the stage and take their seats. And once everybody is seated, we will start the session. Thank you. Our speakers today are Mr. Salah Al-Mahmoud, Mr. Mohammed Anas, Dr. Mohammed Osman, and Dr. Faris Al-Malki. Thank you very much. Following the panel, we have a keynote address. It's been added to the program. It is a repeat from earlier this afternoon. And we have engineer Sami Sarhan, who is from the NIDC, who's talking about Industry 4.0 and the human-centric adaptation, Industry 5.0, and drones. A very knowledgeable presentation. So after the panel, please join us for that keynote address. Thank you very much. Good afternoon, panelists, and thank you very much for joining us today. Before we start the real conversation, what I'd like to do is if we go down the row, and if you introduce yourself, where you're from, what you do, and if you have anything to do with drones. Okay?
Sure, thank you.
Although we're at the drone show.
Definitely, a little bit, James.
All about drones,
yeah.
right? Okay, so let's start with you.
Good. Good afternoon, everybody. My name is Salah Al-Mahmoud. I'm the chairman of director of 9/10, a company based in Saudi Arabia, specialized in UAVs and drones. I've been working in this field for about 15 to 17 years in the aviation, computer science background mixed with the business administration. Work with a lot of international companies, BAE, Raytheon, Lockheed, and so forth. I'm happy to be with you. I'm not going to take too much time. I'll leave it for the rest of the questions.
Thank you. Anas.
Good afternoon. I'm Mohammed Anas. I'm founder and CEO of Inord. Inord is based out of India. We are in business for half a decade, and we have contributed in formation of policies in India for drones, PLI and DLI. Also geospatial policies, utilizing the data safely, and some critical component development as well. So we at Inord are building drones which are capable of utilizing on-edge capability. Yeah, that's a brief of Inord. Thank you.
Dear moderator, Dr. James, thank you for invite us for this session. Mr. Saleh and Mr. Muhammad and Mr. Dr. Faris. Actually, this session is very important because it's talking about the drone is one of the pillars for the Vision 2030. Actually, all these people attended in this session, he's participating by default in this vision. Actually, the drone as one of the pillars of the Vision 2030, it is critical role for the
Sorry, Doctor, can you just introduce yourself so people know where you're from?
Okay.
I don't want the conversation to start yet, okay? Okay.
I'm Dr. Muhammad Usman, as the CEO of Drone Tech International. One of the companies working to supporting the Giga project here in Saudi Arabia, working the developing of the ecosystem of the drone to shaping the future of the drone solution here. Thank you.
Dr. Faris.
Hi, yes, this is Faris Al-Malki. I'm professor of aerospace engineering, satellites, drones. I've been working in this industry for 15 years. I have many collaboration groups here in the Kingdom of Saudi Arabia, UK, and also in Asia. Anything flies, including CubeSats and satellites, as well as, of course, UAVs. It's my research area. I published more than 100 articles regarding this topic. Yep.
Thank you very much. So first question to you, Dr. Faris. How drones are currently accelerating digital transformation in Saudi Arabia. This is a big ambition, isn't it? And where do you see the ambition and the transformation? Where are they?
Yeah, sure. When we look at the Saudi vision, we can realize 3 main pillars and 10 programs and 96 objectives or goals. 33% out of these goals related to digital transformation and any topics that related to the 4th industrial revolution. So UAV is, of course, one of those pillars that belong to the 4th industrial revolution. It sounds promising, yes, but it's achieved many goals regarding this in the academia as well as the industry. For example, at the academia side, I would say various projects here in the Kingdom of Saudi Arabia at Taif University, for example, CAUS, I work with them for various projects, Prince Sultan University as well, and many others. They fund the projects not only for the sake of publication, as they accuse us as an academic, just for the sake of publication, but also it is for prototyping, testing, and also manufacturing, which is the added value for this aspect. I can see it's thriving. We saw the presentation from Professor Khalid. He presented a very good case for CACAS, and they show a real prototype. And one of my projects run by these students, they presented their work here. They use the UAV for mining, which is one of the topics and one of the fields here in the KSA. So I'm seeing it's promising, as well as it's achieved most of the goal so far just before 2030.
So we see education of the next generation of designers in drones, and that is part of Vision 2030 as well. Is that correct?
They are. If you look around this exhibition, I would say maybe most of them, they are young generation, either from the Saudis or even the international, which is aligning with the Saudi vision. Youth, supporting and empowering, I think it's achieved that one. And I can see they are very fascinated to use this kind of technology, not only using it, but also improve it and develop it from the hardware and the software perspectives.
Thank you. Dr. Osman, from your perspective, your organization, how are you contributing to this transformation? Can you give us some examples?
Actually, if we look at the drone market now, expanded.
As close as you can to the microphone,
yes.
please.
Actually, if you look at the market of the drone now, is expanded. If you compare it from 2016 to now is 2025. The value of the market now in 2025 is around 2 billion USD around the GCC countries. Saudi Arabia now, from now to 2030, you see the market will be have a growth from 12 to 14 percentage from the 2025 to 2027. This actually is reflected on the application of the drone, the demand of the market in many sectors. If you're talking about the oil and gas sectors, agriculture sectors, and defense also, this market, it will be enhanced year after year. Yes, sir.
Good. And Mr. Al-Mahoud, you have quite a big booth over there. I couldn't help notice it when I came in. So obviously 9/10 is contributing in some kind of way. Tell us where we are on this journey to transformation in terms of drones.
Beautiful. So at 9/10, James, we have been contributing across different sectors. Obviously, one of the hot sectors is the construction sector, where we see a lot of mega projects under the Vision 2030. We name it LilYoum, Red Sea, Qiddiya, and other projects. These projects we're contributing in the first early phase, where we use the drones for site surveying, data processing, digital twins. It's a big win for this project to crash the schedule and make sure meeting the objectives and exceeding the expectation. We have seen applications that we have worked with in mature sectors, like the oil and gas, where we deploy the drones, payloads, and different technologies related to this, and AI in inspection, where we mitigate any risk that has to do with people going through the oil refineries and other facilities. Agriculture is a part that I enjoy personally. There are a lot of initiatives there that we're doing. It's almost a green field to Saudi Arabia. And the good thing, James, and I have seen it, these mega projects are not born yet. And from a strategy point of view, if you get the drone technology into those projects, you're putting them in their DNA. And this is completely different than when you go to a mature industries where you're trying to penetrate and make that drone operation and technologies, what we call it CONOPS, concept of operation, part of the rhythm in those companies. So I think we're lucky in Saudi Arabia to have to actually have the drone industry picking up while we have the Vision 2030 under construction. We have also things that we're very excited to contribute to it, which is the sport. You know, the Saudi Arabia, we're hosting major events when it comes to the World Cup in 2034 and the Asian Championship in 2027. We're contributing in that part and other sectors. So in recap and resum, we're having bits and pieces in each sector of the economy.
So in terms of sports, is that crowd management technology, or is that during the construction phase?
For the sport?
Yeah, for the sport.
For the sport, so we're engaging with them from the beginning when it comes to the building the stadiums.
Okay.
So picking the right stadium, having the site survey, 3D modeling, envisioning how the stadium precisely what gonna happen, and then kind of going back to square zero and mitigate any risk there. With the data that you're capturing, it's second to none comparing to the traditional ways. So that's the exciting part that we're contributing in.
So using that technology to create a digital
Absolutely.
twin and then plan it from there. Interesting, interesting. And as from your company's point of view, what's your contribution to this transformation piece in context of drones?
Yeah, so if we see the vision of Saudi and the potential we talk about, it's one of the most potential land in the world. So when it comes to technology like drones, a lot of solutions are already being developed and deployed, as we can see and discuss with people. Now, when we see 2030, we see core development, back-end development of it. Front-end operations are already happening. Ground user adoption is already there. And the penetration to the market is already happening. But when it comes to the back-end development, that thing is a part of the vision, I think. Because at the end of the day, what matters is the data security and control on the supply chain. Also, redundancy on the supply chain. So first, we need to identify where everything is, how the landscape is right now for the equipments and the components and the softwares and the securities. Because on one side, on one front, we are deploying these machines to do the service, but what about the back end of it? So that perspective we need to bring collectively, and that can be a part of the vision to make it successful.
Thank you.
Thank you.
Dr. Faris, I'm going to come to you next and pick up the point that Salah mentioned about embedding drones into the operations in terms of the beginning of a project rather than just an add-on augmentation later. Do you think that there's work to do on long-term policy in terms of industrial policy or aviation policy, or even, you know, sort of from the development construction types of regulations, where we can see drones being embedded at that level?
Yeah, of course. If you think about NIDLIB, for example, here in Saudi Arabia and other projects, they use it for various purposes. And you mentioned some of that for construction. Aramco, for example, they use it to monitoring the pipelines. Using that drone or that kind of technology for saving people's life or the operators, I think it's a priority here in the kingdom. That's why they put so much regulation and some limitation for using this kind of technology, and that's why we try to push the boundaries as much as we can. I can say some examples that I experienced myself. There are various places here in the Kingdom of Saudi Arabia, it's not unexplored before. So using the drone to explore some of these areas inside caves, for example, in the mountain of like Taif, Baha, Abha, and other places in the kingdom, can't be happen without this kind of technology because it's not safe. I had one of the experiences and the experiments that we use a drone to explore the water shades inside caves. It's crazy, I know, but that's why we use this kind of technology. We have another project I was speaking to Mr. Fahad before regarding using the drones to transfer the blood samples in Mecca. Mecca, we have pilgrims or Hajj, short-term, large-scale events, so we cannot move, for example, ambulances or maybe motorcycles. So instead, we can use the drone, for example, and we did the experiments 2 years ago in Mecca, and we transfer that in a specific box that safe the blood to be transferred. And many other places we can use the drone. That's why companies, as well as government sector, they try to push the boundaries and try to involve this kind of technology, and that sounds promising for industry and, of course, for the economy.
I mean, from what I can see from my side, I can see this digital ambition is very strong in Saudi Arabia. Look at this exhibition. But from the investment point of view, Dr. Osman, what more needs to be done? Do you see where we are now in terms of investment? We have people coming from around the world to invest in Saudi. We have local investors here sitting on the panel today. What kind of framework do we need for investment, or is the framework that currently exists enough?
Actually, this is great questions about the investing, yeah? Actually, now the drone sectors is need more effort to developing these sectors in terms of research and development, in terms of the products, in terms of the drone solution, because drone not just as the tools, the drones deliverables is needing a lot of working to developing the solution for many sectors like Aramco, like agriculture sector, like if you need infrastructure development, NEOM, the line, everything is needing actually more effort to work to developing these sectors. That is mean we needing also needing more investing for these sectors by the many authorizations to developing these sectors. One of also maybe one of the big challenge, localization of the manufacturing here inside Saudi Arabia. Actually, this is need also from the government more supporting in this side to localize the technology, localize the manufacturing. This is one of the challenge. Another challenge, like upscaling of the engineering, Saudi engineering, need also more effort to increasing their capability to work in, to engage with this, because as you know, now Saudi have a huge project, have a huge infrastructure project development, and need more effort to upscaling the engineering capabilities. And also, besides that, the regularity framework we now is enhancing a lot, yes, but also needing more effort to make all this work approval from GACA like that is more smoothly with the operations now. This, in my point of view. Thank you.
Mr. Nas, do you have anything to add to this investment piece that we're talking about right now?
Yeah, I think I'll first put a perspective of India and then relate it with Saudi as well. What we are doing in India, there is a requirement of national level policy for drones, which defines most of the things. And under that scheme, we try to bring everyone together in terms of academia, people who are into designing, into operations, into servicing as an MRO, and how this ecosystem is going to work. So with this idea, I think similarly some national level policy need to be placed with respect to the Vision 2030. And in that, we can cover up the essential points which he mentioned about localization and creating critical components, because manufacturing is important. We cannot be dependent on logistics in most of the time when it comes to the development of the drones. So localization and local development, Saudi made, is required. And for that, not only hardware, but also software, also design. So it can start in like different phases, because it is always about problem building or buying. When a country have a lot of capital, they can always go for buying rather than choosing building. But you need to have a good combination of building and buying while making a choice. What need to be built, in how much quantity, and what need to be bought. So if we make a good combination of building and buying here in Saudi, we can really achieve more in terms of local manufacturing and IP generation and creation. Thank you.
Thank you. Mr. Al-Mahmoud, from your perspective, which part of the ecosystem requires more investment or less investment? Because we have the drones, we have the spare parts, we have the packaging, or the charge cases, the education piece. Where do you think the investment should be going, and what's the investment environment right now? Is it high confidence, confident, low confidence?
That's a good question, James. So in the drone industry and UAV industry, this is an industry where we see rapid changes. We wake up in the morning as people are working in the field and we see things upside down. A lot of changes, significant changes. R&D are producing a lot of technologies. And I think to your question, in my humble opinion, it should be tackled by all the aspects. And what I mean by this, there should be an investment when it comes to education. There should be an investment where the regulations, designing the regulations, frameworks, policy, procedures from government entities like GACA and GEOSA. And by the way, we have seen good progress so far with the last batches that have been released by the two government entities last month when it comes to the regulations. We have to see an investment with the logistic on how to import drones and spare parts and payloads that comes with these packages. There are a few challenges that we have seen it in the past due to geopolitical reasons. We can't bring the drones and spare parts, but now things are moving fast. We have to see an SMEs, subject matter experts, R&Ds, universities, educations to invest more. So, in my opinion, I think it's a 360 investment. It's a premature field where wherever you shoot, it's the right shot.
So do you think an exhibition like this is forming some kind of function that the industry can coalesce around and kind of, you know, create some kind of critical mass?
Absolutely, absolutely. Those kind of events that we were starving to see it. We look forward to see it, James, and every year to see those people are coming together, having that discussion. And we have seen also government entities that related directly or indirectly with in this field to discuss these challenges. The way they used to be a traditional way to take time back and forth. Now this is the place where you resolve the issues on a spot with SMEs, with people that are involved in the market.
Excellent, thank you. Dr. Faris, actually I'm going to come to you last, okay, as a researcher. So what I'll do, I'll go to Dr. Osman. Cross-sector collaborations in your organization, who do you work with and why do you work with them?
Actually, the ecosystem needing the collaboration between the industry and between university, research and development entities like that. This can accelerating the solution for drones, the product market fit, because there is some, in my point of view, there is some isolation between the research entities and also the industrial. Research entities developing some product maybe is not fit to market. We need like collaboration between industry and also between the research institute to developing some product fit to market to survive, like oil and gas inspection, like infrastructure developing, like and so on. This actually is a key challenge should be work between the industry and research institute.
Thank you. Mr. Nass, I mean, from your experiences coming in as, you know, bringing technology into Saudi Arabia, who are you collaborating with to make a success of your company?
Yeah, I think collaboration is the key to success. So in India, we believe in collaboration. And if you see the history of India as well in terms of the resources, human resources being deployed across the globe and helping countries achieve their goals. So we can for sure be a good asset to this country as well and help contribute to the vision in terms of development of the core competency in terms of components or IP or operations, both the things. And this will happen by sharing values, what we bring to table, maybe some competency or our expertise that we have done in past, we have proven in our different terrains and altitudes. If you see India, we have all type of conditions, hot, humid, cold, very high altitudes, low altitudes. So if it is something is proven, being developed and recognized there, it can be deployed to another part of the world. So that sort of idea and collaboration will come forward.
Thank you.
Welcome.
Okay, so second last question. Mr. Al Mahmoud, I'm going to ask you about the future of drone technology in Saudi Arabia. Where are we going to be by 2030?
I think, James, when it comes to the expectation, and again, my personal view, I think there is no limit when it comes to the drones and UAVs under the condition that we see very mature regulations and framework, which is what we have seen so far from government entities like GACA. as I said, we're building Vision 2030 mega projects. We're lucky to have the drone industry moving and progressing, where we take this and add it to the vein of these projects, the DNA. So in 2030, what I see as these kind of projects mature, finalize. However, when it comes to the operation and maintenance and the part of sustainability, drone is a key role playing in that part. We're going to see it in the agriculture, we're going to see it in the delivery, we're going to see it in other factors of the ecosystem of Saudi Arabia.
Thank you. And last of all, Dr. Faris, I'm going to ask you the same question for your opinion on the future of drones in the kingdom.
Yeah, I would say, first I would like to give it a slogan. It's beyond imagination, real. I witnessed that myself when I went to NEOM. They have a specific center for UAVs. So they put this as a key role of manufacturing as well as using that. The only contribution that I would love to see, and I'm 100% sure that will happen, we will see more fleet of drones. Not only a single drone, single job, but we will see a fleet of drones. That's what I have done during the last 2 years, and I'm expecting that to be happening. At the moment, we use that only for LED drones instead of fireworks, but I'm sure we will do that for the logistics, etc. The second point is heavy lifting drone. I worked with Subul, SPL, the Saudi posting logistics. They are thriving to use this kind of technology for heavy lifting drone instead of traditional trucks. So for sure we will see this kind of industry will thrive and growing anytime soon.
Actually, we've got time for one more round of questions. So all the people sitting out there looking for business opportunities in the drone industry, right? Just as you gentlemen are looking for opportunities in the drone industry, if you were going to advise the audience here about what kind of business opportunities exist, I mean, 9/10 looks like it's doing a good job by the size of your booth. So what kind of business opportunities should they be looking at?
Good. Well, I'm going to ask for a commission at the beginning, James, if you don't mind. No, I'll leave it for the team. So, as I said, it's an open door, in my opinion, to invest and do the business. From procuring the drone, that's one part that you can focus. You have a lot of international OEMs, different brands. You can operate the drones when you focus in this sector. There is a lot of demand, big demand on the operation, maintenance, and after sales as subject matter experts, expertise. And there's one part actually where I see really big needs, which is the consultation and advisory. We need that, and especially in this phase of the journey of building the capability in drones. Obviously, the manufacturing the drones, the localization, is other aspects like Dr. Faris mentioned, and the rest of the team. So I see, potential in each and every single aspects of the drone industry.
Okay, Mr. Anas, what about you? How would you advise our audience, where they should put their money, not just with you, but in general?
Yeah. So it's a good place to work. So the advice that or the idea that I can share, it depends on what stage the person is. Maybe a student is looking to enter into this, so they can invest their energy into R&D and produce something new which does not exist, like some GPS denied problems need to be solved, or like the cave problem mentioned by brother. So these kind of problems can be solved, or swarming problem, making a lot of birds fly together. So R&D investment is also required. That can be done to the people who are coming from education background, from universities. And if someone is trying to start a business, they can more focus on to services. And someone already have a business, they can try to partner with small companies or companies coming from abroad, like Enod.
Thank you.
Welcome.
Dr. Osman, and what would you advise?
Actually, as we see now, and in the vision of 2030, there is a lot of, there is big growth in the drone solution. In the sector of the agriculture, mining, and infrastructure development, even smart cities initiatives, there is a lot of huge opportunities in this sector. But it is need carefully to address or revising the business model for the working, and also how to collect the talent for your project, or for your, if you want to invest in these sectors. It is need more carefully to addressing this. But the opportunities, it is huge. Now drone is a leader of transformation strategies now. Many companies now have awareness about the drones and the application. And these days, we see more applications integrated the drone solution with AI. Actually, in infrastructure, like infrastructure developing, 3D scanning, modeling. And as we see now, drones in many sectors accelerating the process and reducing the cost, and also speeding the timeline for the project, like such as example, Dar'iyya, King Salman Park, and so on. A lot of projects now demand drone. A lot of projects demand solution, even in safety, even in another sectors. I think there is a lot of opportunity, but it is need carefully to revise the business model.
Thank you. And Dr. Faris, I'm not going to ask you the same question. I'm going to switch it round. How are we going to attract more young Saudis to become interested in studying the low-altitude economy, the engineering part, the aviation part? Use your crystal ball. How do we get through to them to even tell them that this economy exists in Saudi Arabia?
Of course, I can see this kind of exhibition and forums and conferences that will attract them to see a real world, real experiment, and real cases. I would say integration and collaboration rather than competition. There are few and a lot, I would say, good example in Saudi Arabia. Of course, we have Mr. Saleh, he's one of those examples, as well as we have internationals as well. I think when they test that through the R&D departments inside the universities or inside research labs, they will taste the success, they will taste the flavor of UAVs as something unique and special. I would say, as far as I see from these conferences and exhibition, I witnessed the last version last year, and I'm attending this one. I can see a great shift, a great engagement with the youngest. Lots of requests and questions. They did ask me, how about the event? Do you recommend? I say, yes, you can go there and see the world. It's promising. It is very promising, yeah.
Thank you. Thank you very much. Let's give our panelists a big round of applause and say thank you very much for joining us today. Thank you. And if I could ask for a photograph down the front here. We have a photographer somewhere in the house. He'll be with us in a minute. There is a workshop going on at the moment. Any test, any time. Windshape and Barcelona Drone Center, which is over here. If anybody's interested in that workshop, please head over there now. And I think we have Mr. Sarhan from the NIDC with us in a moment. Sammy, you're here. Come on down. Come on up, rather. So we have Sammy Sarhan, who's going to give us some wonderful insights into Industry 4.0, Industry 5.0, drones, AI, edge computing. He's got the whole sort of shopping bag of stuff that you guys need to know about. So please come up. And if we could have the slideshow up, please. Could we have the slideshow up for Mr. Sarhan? Thank you very much.
Can we put the slide up, please? Okay, great. So I'm repeating it for the purpose of everybody can benefit from it. So I'll introduce myself very quickly. For those who were not in the morning, in the afternoon at the beginning of the sessions, my name is Sami. I'm the Chief Advisor at the National Industrial Development Center. I help and support localizing Industry 4.0 technologies. Today I'll be talking about how drones are part of Industry 4.0, and I'll explain and I'll give some examples as well. Now, for those who are in the morning here, I keep saying in the morning, those who are in the afternoon, see the slides, please take it as a repetitive knowledge that you would like to learn more about it. Those who are new, so will be able to hopefully learn from this. Okay, so Industry 4.0 is a term that has been repetitively now been mentioned in multiple industrial ecosystems. So when we started back in 1784, Industry 1.0 was basically based on human mechanizations. And when the actual electricity was introduced back in 1870, then at that time, Industry 2.0 was actually born. Then when the .com and the electronic era started, Industry 3.0 started with automation and robotics. Industry 4.0, however, in Germany, Hannover Messe was actually announced that we are now into an era of 4.0 with cyber-physical systems and the rest of the technology stacks, IoT, AI, cybersecurity, and you name it. Now, somebody can ask, is there already Industry 5.0? Honestly, there was not an official announcement, but 10 years after, in 2021, European Commission announced what they call an Industry 5.0. And this time, we're not dealing with technology, rather than dealing with major concepts related to human-centric sustainability and resilience. And the reason is there was a a lot of hype, or let's say a lot of fear from a lot of the people that AI will take our jobs. Well, Industry 5.0 is telling that a human is in the center of the technology. Okay, so that's something I wanted to give. Now, whether we're gonna see new technology or new revolutions under 5.0, I don't know. But all I know that Industry 5.0 has been announced at least slightly. Now, why we're talking about this? So, the reason is we're here today is to explain that there's so many pillars, by the way. They're not limited to these pillars. Drones is one type of robotics, okay? And they are part of Industry 4.0. I'm going to talk a little bit more about why is that. In fact, the next slide it is. But I want to also shed light quickly. There are other technology pillars. We're talking about, obviously, AI is one of the major pillar of Industry 4.0. IoT, robotics, additive manufacturing, and what have you. All of these are actually major pillars of Industry 4.0. Now, why the drone specifically is part of Industry 4.0? We all know that Industry 4.0 is data hungry, okay? It consumes a lot of data. It will require a lot of data for you to be able to do things with it. So for example, we know that AI, for example, is built based on a lot of data. It takes a lot of data. Now, drone is a data generator. Okay, they generate data from areas that cannot be done by any single or other cameras. For example, anything related to flying data, anything flying over asset, reaching to areas that cannot be reached by a regular camera or even with a CCTV camera. So if you install a fixed camera at a corner of your facility, it will only show you a specific angle. However, now drone can actually fly over your facility. In fact, I was at the exhibition meeting a company there that just flying over the facility, it will generate for you the 3D models right away. It doesn't even have to wait after that. So you can imagine now, a drone can be a mobile IoT platform in the sky, providing data with all the information that requires and immediately feeding it to your Industry 4.0 systems. This could be AI, digital twin, anything related to analytics, anything related to predictive maintenance. That's the angle I wanted to talk to you about. Now, just like Industry 4.0, when it started with human and going all the way to automation and autonomous, a lot of machines now in the factory will not require a human. You set it up, it understands what it takes for it to produce. Similarly, drone is going through that particular transformation, okay? Today, we're looking at pilot, and I think majority of drones are actually flying by pilots. However, someone can argue with me as well that there are also a lot of automated drones. We know that there's a lot of softwares or drones coming with software that can fly automated. However, I'm not sure if there are fully autonomous drones as we speak today, okay? There are real-time AI advanced sensors and additive decision-making. Now, an analogy could be Tesla car, okay? Today, when you drive Tesla, you will actually collecting data as you drive, right? And you become adaptive. That's the whole idea of machine learning. You learn as you go. So I think we will reach to this. This is not so difficult. But let me tell you exactly what do we mean. So when we talk about autonomous, the industry have identified a very specific level of autonomy, okay? We're talking from level 0 all the way to level 5. Now, today, I'm not sure exactly if we are at level 5, but if you look, for example, what does the pilot or the operator have to do? At level 0 and level 1, it's 100% pilot drone. However, in level 5, the operator set the objective and the drone fly by itself. Okay, you just set the objective. I'm going to explain in my next slide what do we mean by that. Okay. Now, another thing, with what level of understanding? Okay, so there level 0, level 1 is no understanding, some sort of understanding in orientation and altitude. However, in level 5 is full understanding. Do we have that? I think we're still, the technology is still going on to bring it. Now, let me give you a good example. This is a proposal that I put through at the Robotics and Autonomy Conference at the King Abdullah University for Science and Technology. The idea was that you have a drone in a box. That drone in a box, you actually feed it with some data and information, and then the drone can fly by itself to do its operation. Let me explain. So, for example, you set a specific objective, why this drone is actually flying, okay? So you tell it it's a construction site. I want you to take a specific corners of the construction site. You actually set a geometric boundaries. You tell it exactly where to fly, at least so that it doesn't go beyond that boundary. You actually asset identifications. You already identify some of the asset, if possible. So you tell it there is a crane, there is expected to be some sort of asset other than those. And then also you will tell it about the work shift. All of this information is now fitted into the drone. In addition to scheduling data, for example, you would like the drone to fly during a working hour, so it will actually understand what it takes for it to be able to capture. And then the drone will plan its own mission, okay? You already gave the drone the information required for that flight. Now the drone will say, okay, well then, you know what? I think the best time to fly is from 1 p.m. to 3 p.m., something like that, okay? You also it will send the data instantaneously. So somewhere at the server, at the cloud, at the workstation, somebody will be exactly getting those data right away. Process data on board. Now with the edge AI chips that we have, those data can easily be processed on board and be sent directly to the center. Fail-safe and energy control. So for example, as soon as it finds a problem, it will go back to the base. As soon as it finds that the battery is actually draining, it will go back to the base. And finally, any abnormality detection. So for example, if God forbid there is a fire and there's a smoke, the drone, while it is actually flying, it was never programmed to look for fires or smoke, but it will immediately send the data that there's something abnormal happening, and it will detect it. So this was a proposal then. I think the technology slowly will actually go there. I'll give some examples. Now, if somebody asks within the Industry 4.0, within the factory or the plant, where and how drone can actually help, there are many examples, honestly. This could be limited in my slide. Safety and compliance, autonomous inventory management, I'm gonna give an example right away. Predictive maintenance, integration with IoT. Now we know that Internet of Things is becoming extremely important in any plant now. That could be something that we use for feeding that information into it, an autonomous industrial ecosystem. For example, IKEA has implemented a drone within its warehouse facilities in Europe and US to reduce label strains, fewer misplacement, improve accuracy, and that can be flown 24/7 within the boundary of the actual facility. Now, a good question is that when autonomous drone work best? Infrastructure and asset inspection. I'll give an example in a minute. If you have a large plant and you really want to make sure your asset you're monitoring your asset, then typical application is energy sectors when inspecting oil tanks, pipelines, or power line. A very good example, this is a company called Delic in the US, already using perspective drones for daily autonomous operations. It's a drone in a box, goes out, look at the flare, look at various different assets, and send that information immediately. Another one is flyability. ALOS, always known. It feeds data, it goes into areas that a human cannot go. It goes into pipeline, it goes to manholes, and be able to give you a precise 3D data collection and obviously feed it into the digital twin right away. Another best place to use autonomous drone is when you have some sort of continuous monitoring. Let's say you have a site, you have a construction site, or you have a large agriculture site, and you would like to monitor that on a continuously basis. You program it, you set the objective, you put the boundary, the drone goes out and actually be able to give you information right away. Finally, this is very, very interesting, gas detection areas where you have some sort of regulations and policies that will limit you on the types of gases. This is something that you can launch the drone and it can be able to detect gases. And not only that, it will actually show you the exact location of the gas emissions. So these are some of the applications of autonomous drones, or the idea of using it in Industry 4.0. Now, these are my two last slides. I wanted to show you this, that Industry 4.0 investment opportunity in the kingdom is very, very promising. By the way, this can be actually accessed through the website Invest Saudi. If you go there, you'll find a lot of investment opportunity. But just looking at the demand in the market by 2030, we're talking about $17.8 billion of demand for Industry 4.0. Obviously, you have a major drivers. Yeah, there's a global trends as well. The market is just to grow. It's not gonna, it's gonna go low anyway. Obviously, there's a huge value chain, scalability, localizations. The industry is actually hungry, as we say it, for new technology and Industry 4.0. With that, I'd like to conclude my presentation. Thank you so much.
شكرا جزيلا لك مهندس سامي على هذه الإضافات الثرية والنافعة. الآن سيدات والسادة الكرام، نشهد وإياكم توقيع مذكرة تفاهم بعنوان Any Test Anytime بين شركة وينشيب كومباني وبرشلونة درون سنتر. فليتفضلون على خشبة المسرح لتوقيع مذكرة التفاهم. سيدات والسادة الكرام، بهذه اللحظات نودعكم ونشكر لكم حسن استماعكم وحضوركم ومشاركتكم. وصلنا وإياكم إلى ختام أعمال اليوم الثاني من سادكس 2025. يرحب بكم المعرض بأجنحته المختلفة اليوم وغدا بإذن الله تعالى. شكرا جزيلا لكم والسلام عليكم.